A standard 500 square foot residential garage has the physical capacity to generate over $1,000 in daily net profit. We are looking at a space traditionally meant for 2 cars, now running as a packed, humming production floor. This split-screen data visualization shows the extreme ends of that profitability. On one side, an adhesive tape production line, netting an estimated $44,000 daily. On the other, a simple wooden cutlery molder, pulling in $1,200 a day. Both fit inside the exact same footprint. The modern residential microfactory abandons hobbyist tinkering. It relies on high-yield, semi-automated machinery operating within these strict physical dimensions. To pull this off, you have to treat a domestic garage with the exact same operational rigor as a traditional industrial plant. Online influencers often pitch this reality through exaggerated claims, like suggesting you need a network of 1.5 million machines to reach a viable manufacturing scale. The actual challenge for an operator is entirely physical. You navigate precise unit economics, heavy equipment specifications, and severe infrastructure upgrades. Actual success comes down to abandoning those marketing delusions and systematically solving your physical layout and power constraints. This flowchart maps specialty commodity machinery. A $4,000 cutlery molder outputs 3,000 pieces an hour, while a tape line churns out 40,000 rolls. To maintain this, you must store massive quantities of raw materials, quickly overflowing a home garage's square footage. Additive manufacturing offers a different spatial profile. A 3D print farm can be built using turnkey FDM machines costing between $1,000 and $2,000 each, or custom builds like the MP3DP or Voron, running from $1,350 to $2,000. But there is a reliability trade-off. Standard FDM systems using low-cost thermoplastics experience failure rates of 25 to 50% without advanced automation. Achieving industrial-level yields is bottlenecked by 2 things: the physical limits of your material storage and the baseline reliability of your machines. Moving into heavy-duty subtractive manufacturing requires massive hardware. The Langmuir MR1 gantry mill weighs between 750 and 900 pounds. That mass buys extreme capability. It can remove 30 pounds of steel per hour with a spindle runout of less than 0.0003 inches. To safely absorb the violent vibrations of that machining process, the mill must be bolted to concrete-reinforced steel structures. Hybrid AI-driven metalworking helps solve that footprint issue. The Reli Laser 1300W shrinks the traditional metal shop by combining welding, cutting, and rust removal into a single desktop unit. Yet the safety hazards remain industrial. Processing heavy stock like 6mm stainless steel still requires professional material handling techniques, like the use of non-marring slings. Before we get to these weird, boring, and highly profitable business ideas, let's talk about your legal foundation. You absolutely cannot start a unique niche business without a properly structured LLC. Think about it. Whether you're operating heavy industrial machines or managing a messy local service, the liability risks are very real. Most people start these hidden gem businesses as sole proprietors, which means if a machine malfunctions or a client files a lawsuit, your personal savings and home are on the line. Your business must be a separate legal entity to protect your personal assets and keep your home address off the public record. That's where Northwest Registered Agent comes in. Northwest is the absolute best formation service out there. They handle your entire LLC setup for just $39 plus state fees, which includes a full year of their premium registered agent service. What makes them elite is their privacy by default policy. They use their own business address on your public state filings, so your home address stays completely hidden. Plus, they never sell your data, and their corporate guides provide real human support whenever you need it. This legal shield is non-negotiable. I've linked my full Northwest review in the description. Use my link down below to register your LLC today and unlock exclusive discounts. Get your protection handled first, and then let's get into the ideas. Subtractive and hybrid manufacturing offers extreme precision, but it demands rigorous structural integrity and strict safety protocols to operate in a residential setting. To run 24/7 without a human operator, 3D printers require continuous automation hardware. Systems like swap mod belt kits and thermal release cooling fans allow the machine to autonomously eject finished parts and start the next cycle. Setting this up takes high technical proficiency. You must configure centralized task delegation software and deploy Raspberry Pi network isolation to keep the hardware secure. This diagram shows how to extract dual revenue streams from a single machine, like a cold oil press costing around $2,000. Raw seeds convert into premium oil at $6 to $12 per liter, while the waste seed cake converts into sellable animal feed. The catch is logistics. You have to secure consistent local supply chains for raw seeds at $1.50 to $2 per kilogram to keep the press running. Leveraging strict automation and zero-waste models is the most reliable way to maximize the financial output of a highly constrained floor plan. This diagram shows the severe power grid constraints of a home setup. Plugging in multiple CNC mills, CO2 lasers, or print arrays will instantly overload a standard home circuit. You must install a dedicated 220-volt subpanel. There are also strict thermal envelopes to manage. FDM printing mandates maintaining an ambient temperature of 15 to 28 degrees Celsius to guarantee part quality. Operators go to extreme lengths to solve this, sometimes utilizing cryptocurrency mining rigs in the winter just to affordably heat insulated enclosures. Then there is the final logistical bottleneck. You absolutely must design dedicated packaging and shipping stations into your layout. Overlooking the footprint for cardboard boxes and labels routinely forces operators to rent expensive short-term flex space, up to 2,000 square feet, to handle production surges. The true ceiling to garage manufacturing is rarely the speed of the machine. It is the electrical and logistical capacity of the building itself. The advantages of this model are significant. You can generate between $100,000 and $44,000 in daily net profits, achieve industrial scalability without permanent commercial leases, build zero-waste dual revenues, and run 24/7 autonomous production. The disadvantages are just as real. You will face severe power grid constraints, high upfront capital, like $12,000 to $25,000 for professional CO2 lasers, severe footprint bottlenecks for materials, and mandatory environmental hazard controls like HEPA filtration. The decision to launch a microfactory rests entirely on your willingness to balance that high capital investment against those uncompromising physical realities. The $1,000 a day microfactory is a highly viable reality, but only for meticulous operators who treat their residential garage as a true industrial facility. Success requires non-negotiable investments: installing dedicated 220-volt electrical subpanels, integrating automated part ejection hardware, and maintaining strict workflow logistics. Underestimating the space needed for raw material storage or the thermal demands of your machines guarantees failure the moment you try to ship an order. If you are building out your floor plan, focus exclusively on high-margin, single-product niches. Automate relentlessly and secure your infrastructure before you buy a single machine.